Yes.
Yes, I don't know, it seems that I'm audible enough. Uh, so, any question as we wait for others guys to join? Any person with a question? As we wait for others to join. Dar is having a question. You can unmute your mic.
No, I don't have question now. I started.
Dar, do you have a question? Uh, any question about yesterday's lecture or any other lectures we have been having? As we wait for others to join. And I'm hoping everyone, each and every one of you has gotten the assignment 2 results. If you did submit, any question? I want to share my screen. Can someone confirm that you guys you are able to see my screen from your end? Yeah, yeah. Okay, thanks. So today we are just going to start off immediately because our lecture will end at 8:10 today, around 8:10. So Collins is having a question. Unmute your mic, Collins. Collins, you can just unmute your mic. I can see you have raised your hand. Collins, can you hear me? Ichuhe. Yeshua, you're waiting for you to ask your question. Or any other person with a question. If no question, you can just continue with what you were doing yesterday. I was just saying that yesterday we introduced ourselves to Matplotlib, which is a Python li library and it has some module called Pipeplot, which is used for visualizing our data. So let me just share my screen again. So, I can see Collins is still up, but he isn't saying anything. I think we can just continue. So yesterday we learned how to Dar, you had a question. Just unmute your mic and ask your question.
Hello?
Yes.
Yes, I have a question. Huh?
Uh-huh.
You said you have shared, I don't know, the data for, is it was exercise underscore?
Yes, it is already shared in the group.
Oh, I don't know, but I found the one lectures 8 and 9. Is it this one? The same?
Which one? Yeah, it is that one. For are you seeing the data that I had indicated use on assignment?
Yesterday, yeah. No, not for assignment.
Yeah.
For class of yesterday.
Yesterday I just sent you the notes and the programs for yesterday's and today's lecture.
But you change the data. Okay, and where is this data? Because I can't find it.
Data at the moment we are just using numpy arrays.
Okay.
Collins, Collins, you can just unmute your mic if you can hear me. So I was saying that yesterday we learned how to do simple plots. We learned how to draw a line graph. And I just want, and also we learned how to draw a dotted line. So today I want us to add some labels in our graph, because a graph should have every graph should have a title, should have the labels of y and the x-axis. So that is what I want us to do now. So let's just have a program to illustrate that. And I want to use this example here. So I'll just copy this code and paste it here. Then I'll just explain what it does. So we said that our first step is to import both NumPy and Matplotlib. And then the second thing is to define our x and y values. So in this case, we're using the NumPy arrays, and we have our x, which is assigned an array of some values, and we have our y also, which is assigned some values. So to plot, we just say that we use the the PLT variable to invoke the plot function, and then we just pass our points, or the x and y points in that function, as you can just see here. From that point now, we can add some. I think I can just comment out this one, and then we try to run these. Then we'll see our output. I think the output is just below here. I'm not wrong. So is it below? Let's check. This one is for this code. There is for this code. And I think it is still running. Yeah, it is still running because it is connecting to our kernel. And then let's just give it time to run. And this is how we add some labels. I think you can just move with the code that is or we just wait for this one. It's taking much longer. I don't know why, but we can still wait for it to run. Yeah, I think it's okay now. This graph itself, you cannot know what it does. Just some values here on the y-axis and x-axis, and just a line. So it's a good practice to label your graph, whether it is a line, scatter, or any other type of graph. So uh, is there a person who is having a question? Someone has just raised his hand. Pashamai.
Okay, I have a question. Then after you write the code, do you run, or where do you how do you do about it?
After writing the code?
Yeah.
You just run the code, nothing much.
Okay.
Like you have just seen here, I have just hit this button, this play button, to run this code. So you write your code and then you run it to see the graph. Are you facing some difficulties in running the code?
Yeah, mine is still loading.
Yeah, it will take a while. So you can just give it time as I explain how we add these x and y labels. So I was saying that a graph like this, it's incorrect because it doesn't have a title. It doesn't have some labeling on x and y axis. So it's important to add labels, and how we do that. Our Matplotlib, the pyplot some module of Matplotlib has a function that is called the x label to add the x-axis label here, and also it has a y label function to add to add to label the y-axis here. So we are just going to uncomment these lines and rerun this code to see what happens. I think now you can easily tell what it is on y-axis and on the x-axis. So we have the average pass on x-axis, and we have something to do with calorie burnage on the y-axis. This is how we do add the x and y labels. So in a question, I think I can just comment out this one to say labeling. I think that is it. It is as simple as that. I think you can just move forward if there is no question regarding labeling. Any question? I think you can create a title as well. And how we create that title is that also we have a function for that purpose. And what we need is just invoking that function right here. Let's just write it here. So we are going to have the PLT. Then we have dot title function. And then we just pass the title. For this case, I don't know the best title. I'll just call it our title. Our title. So we can just rerun this and see what we get. You can see now our graph is having some title, is having some labeling on x and y axis. This is simply how we do it. It's quite easy. So any question on that? Any person with a question? And I can see most of us have not joined yet, but we'll just continue as we wait for them. So, Piriska, do you have a question? Piriska, do you have a question? Ronnie? Ronnie, do you have a question?
Good evening.
Yeah, good evening.
No, I don't have a question. I'm following. I've been absent for almost the past of last week and this week. So I'm catching up.
Oh, okay.
Yeah.
Any other person who feels that he needs some clarification? I think we can just continue. Let's just continue with the other part. or we can just have another. No, let's just continue. And let's go to, we can also add some the grid lines, and with Pyplot you can use the grid function to add grid lines to the plot. And I think you can just add the grid in our example to see how it looks like. Yeah, it's right here. We can let's comment on this and add grid. So this is how we do it, the plt dot grid. And then you can just rerun this code. I think everybody can see the graph has just changed. At least now you have grids, these square boxes in our graph. So I think you guys can now see that this library is just helping us so much. You don't have to hustle to do some functionalities like adding title. Like you just write one line of code, and then and then you get things done. So that is the best thing with Python when it comes to visualization. So I don't think anyone is having a question. I think you can just try it in your Anaconda, and then by show of hands, who has implemented that? Let me see. We have Pashamai has implemented that. Any other person or only Omar has done it? Any other person? Aaron? Victor, have you implemented that? Or you're still in the process? Yeah. Victor, can you hear me? And Collins, I want us to move together to implement these functions. So you should not be left behind. Dar, have you implemented that? You can just write in the in-call messages, or you can just unmute your mic and tell us maybe if you have done that.
You called there or something?
Yes, you, Dar.
Okay. Me, I have tried, but I don't know what is the issue exactly. Yeah, I can't figure it out. But I have tried many times.
Oh, okay.
So now I'm following, yeah.
Or like drawing the graph.
Yeah, sometimes I put the code. When I run, I don't know, it's not running.
So are you able to
And
share your,
then
are you able to share your screen? Maybe we can help. We can chip in.
let me log in by my computer, then I will try. But you can continue at this time.
Okay. Any other person who is facing like some issues with drawing the graphs? Okay. Let's just continue. So we can just change the position of the title, and we use the log parameter in title function to position the title. So we have the legal values which are left, right, center, and we are told that default is always center, as you have just seen. In our we have just seen in our graph here below. Let's see that again. As you can see, we didn't specify the title position, but by default it's always at the center, but you can change these. Let's just try to change this and take it to the right. So you can have log and then is equals to, we pass it right, and then we try to rerun these, and you can see our title has just shifted from center to our right, and you also do that if you want it to be on the left. It's just that simple, you see. Yeah, it's just that simple, but just adding the log or the location you want the title to be. I think there is nothing much to discuss at that point. I think we have just seen how to add some grid lines in our graph, and we can just try this with a different program so that for practice, let's just have another program here. Just add comment this. So our first step is to import our libraries. So at this moment we have to, and then we can just define the array, and that is the x and the y points, and then we have just named our title is sports watch data, and then we have just our x label and our y label. So there is someone whose mic is on. I don't know who is that. That your mic is on.
Oh, sorry.
Yes, and then we just invoke these all. We just call this function that is for plotting. Then we just pass our values here, and then we do we just now need to add a grid, and then we want to show that. So you can run these, and then we see again the output. We have our sports watch data, and then we have the X and Y axis labeled. I think it's just like that. We don't have much to learn there. But I want us just to understand how we do draw these lines, and then maybe at the end we will have to use a data set, maybe to draw a graph rather than using these hard-coded values here. So we can just continue. To the other part of discussion. I think we have discussed that. Then let's see how we display multiple plots. You can just have more than one plot. So with a subplot function. So you can see we have a lot of functions in this library. So I think I'll give you a link to read about the functions, because there are so many. We cannot be able to cover them all at this discussion, but we're just going to cover the ones that are relevant at this moment. The others are equally relevant, but you will learn them at your own convenient time. So let's just have this example here. By this example, I want us to plot some multiple plots. You can just have our code here, and then you can comment this code. At first, we have our we import our libraries, and then we have the first plot. We'll have X and Y values, and then when it comes now to plot, we want a subplot of 1 to 1, and then we just pass our values here. Then we have our second plot. So we have I think everybody is able to see we have two plots here. I think we can just run this code to see what is the output of it. So the first plot is having a what? Is having a, it's kind of a line, but this one is a zigzag line. Don't know how to call it. And the other one is a straight line. So I want us guys to do this. I think everybody has this code. And now what I want us to do is to do some practice here. So I need someone who will, I'll choose a random person to label this graph of ours. And yeah, I'll just choose a random person to, any volunteer before I choose one person. Let's make this thing fun. So who is willing to label a graph? Piriska, are you ready to label our graph? Yes? Or any other person who is just waiting to volunteer to just label this graph of ours. I need a title and I need a next I need the XY axis to be labeled, and the title should be at the right. So any person who is willing to label for us. Kasora, hey you guys, who is able to take that? Any person. I just need one person, a volunteer this time. Yep. Good. We have Pashamai. You can just share your screen.
Okay, I'm using my phone, so can I just say it?
Okay. Let's just. Okay. Yeah, you can just tell me what to do so that the others can follow.
Okay, so first we put the title.
Yes. Okay. Let's see. Let's just say we are labeling, and the first thing is the title.
Okay, so you just write PLT
PLT.
dot title.
Yes.
Then you open the bracket. Then you write the name of the title.
Let's just call it. What should we call it? Let's just call it a sample title for simplicity. Sample title. Yes. Then.
Okay, so you then you put a comma.
Yes.
So you type a lock or to locate. Then write.
Okay.
Right.
I just right there. So yeah, that is the title.
Then to name the axis.
Okay, I need another person. Let's just have that title labeled. Let's just rerun this. Yeah, good. I need another person to label the y axis. Thank you. Okay, any other person who feels like want to label the x axis? Kasola, I need you to label the y axis, and then we have Pirska to label the x axis. Good. Okay. Who goes first between Pirska and Kasora? Kasora, are you able to hear me? Victor? Victor is ready to take the y-axis. You can just guide us how to do it. Victor? Okay, Kasore is having some issues. We have Victor. If Victor, you're talking on a muted mic. Or okay, I think we can just let's do it together. So let's have these the y-axis label. Axis label. So we are again going to use the PLT, and then we want the y label. It's just right here. I think you have an issue with an indent there. So let's just call it the y-axis. And then we have our x-axis. We have a plt dot x label, and then we pass our title here. X label. Just so, and then you can just rerun this code. Then we see the output of the code. Let's see this. Let's just copy these. Yeah. Then we can have the same here. So let's just rerun this code and see what we got. Good. I think that is that with the labeling of that, and that is how we do have like some subplots. You can even add another one and another one. Maybe if at all you have several plots to make in one page. So that is it with that. So I think we can just continue with the other part of discussion. And let's read through these the subroad function. So we have just like illustrated how we use it. I think we can just take some theory here. So we say that the subroad function takes 3 arguments that describe the layout of the figure, and the layout is organized in rows and columns, which are represented by the first and second argument. So the third argument represents the index of the current plot. So these ones. So we have our first and second argument taking the row and columns, and then we have just the third argument taking the index of the current plot. So that is that with it. We can see now the other one is taking now the second index of the current plot. This was one, and then we have two because it is the second plot. Also, it takes one and two to mean one row, and we have two columns. And this plot is the second plot, so it will take two. So I think that is that. Let's draw two plots on top of each other. I think we can just try to figure out how we can arrive at that. So let's use this good example here to illustrate that. Good. So the first thing we do is importing our libraries. That is the first thing to do. And we have our plot here is x is equals to that, and then we have our np, our y mean is equated to that, the array, and then we have the plot. So at this moment we have two rows, and then we have one column, and at index 1. So then we can just plot that, and then we have our second plot, whereby again we have to repeat what we did here, and then we have that subplot. Then we'll just run through this and see how that works. So you can see now we have changed our graph. Initially they were horizontally aligned, but at this moment they are vertically aligned. So I think that is as simple as that. Any person with a question regarding how we do some two plots on top of each other? Any question? Okay, anyone who has implemented this? By show of hands, let me see any person who have implemented that. Any person? Who is almost? Kasola? Victor, we can't hear you. Just write at the in-call messages. Or Victor is saying that he's experiencing network. Oh, okay. Ronnie, have you implemented that?
Sure.
You almost. Okay, I can just give you guys 1 minute to implement that, so that you can move together. Any person who is done? Pashamai, are you through?
Yes, I'm true.
Okay, you can just share your screen. Just uh,
I'm using my phone, so I'm just doing it on my laptop.
okay. You're also doing okay. Let me just share that code once again. But it is already in the notes that I shared yesterday. But I can share it in the in-call messages so that everyone is able to implement that. Yeah, I have shared the code. Good. So let's continue. Let's just continue as you guys implement that. I think even we have just I think we have another example here, but this time we have added the titles. I think even the other one we added titles, but we can have now an example with already whose title has already been implemented. Let's just have a look at this. Let's have a look at this. So we have the first plot, and it's given the title sales, and the second one is for income. So you just follow the same steps for drawing the plot, and then you just have to add the title. That is the only line of code that has been added in these multiple plots. So we can again run through this code and see the output. And this time around we have sales and income. The income sales and income titles. With this one, let's see where what output. Oh, we labeled only one. I think we can just add the title for the other. You can just copy it right below here, and this time around we will not include the location. You can also have it here. We need the sample title. Let's just copy these, and we have it in our first plot. Sample title 1, and we have sample title 2. Written 1. Let's see it. So let's just run this and see the output. Good. I think now you guys can see we have the sample title 1 and sample title 2 for every plot. So any person who is having difficulty in doing that, I think it's quite easy. So Pashamai, have you finished? And Haji, Haji, are you able to follow? You can just write in the call messages or unmute your mic. So these things they are quite simple, especially when you come to visualization. You just have to master some few functions, and things will just get done. We can have a super title. You can add a title to the entire figure with a subtitle function. Again, you can see we have so many functions. We have like this one for the super title here function. This one will label the entire figure. I think you can just try out that. And how we do that, let's just have a copy of this line of code right here and try to implement it in our multiple plots here. Here's this one. Instead of having to, we can also have we still have these individual individual plot titles, and then we have the super title. So we will just have to invoke this function here. Let's just delete this. Then let's have it commented as super title, and then we just invoke it plt dot the super title. I think it's just right here, and then we can have the super title, super title. Let's run this to see the output. Yeah, good. I think everybody is able to see now. We have a title for both plots. So I think that is that with the plots. I mean adding titles to the plots and labeling the x and y axis. Any person with a question up to that point? Any person? You can just raise up the hand and see before you continue to the other part of our discussion today. I think these things are quite easy. We have already learned how to add a super title. Let's get into some scatter plots. Who have heard of scatter plots? Any person who have heard of scatter plots? Any person? You can just by show of words. I need to know who has interacted with scatter plots anywhere in Excel, be it in Excel or the normal mathematics that we do. Any person?
Maybe mathematics for me.
Sorry?
Maybe in mathematics for me. I don't know the others.
Okay.
Mm.
Any other person who have heard of scatter plots? You guys didn't draw scatter plots in Excel. I think we will see how we implement that right now. Just right now. So let's learn how to create some scatter plots. With PyPlot, you can use the scatter function to draw scatter plots. And the scatter plots function plots one dot for each observation. It needs two arrays of same length. One for you can just bring this one here down. One for the values of x-axis, and the other for y-axis. I think we can jump into an example here. Just a very simple example again here. Let's have this example. So what do we have? We have like you have to do some importation for your libraries, and then you have to define your x-axis and your y-axis value, and then you just again use a function. These things are simplified, like I don't know what. So by these 6 lines of code, you're able to draw a scatter plot just by calling this function here. This is what we call scatter plots. For those who have not interacted with this kind of graphs, so these are what we call scatters, and each point, each dot represent a certain value. I think you guys have seen that, and now I need someone to label these for us, and this time I want a ready to volunteer to label for us this graph. Even the graphs that we did yesterday, they will be labeled, and I'm not the one to do that. You guys will help me to do that. So again, I did a volunteer to and you can have a ready, so that maybe we can have gender balance even in how we answer questions. So any person who is willing to label for us these, you put a title for us, and as you label the y and x-axis. Any person, are you guys following? Ronnie Uma? Or Nathan? I need someone to help us with the labeling, because you should take these seriously, because I don't think there is a graph that will ever draw without labeling. Haji, will you help us with labeling that graph? Or any other person? No one is willing. Moracha, are you following?
Yes, I'm following, though I came in class very late.
Yeah. But I think you can. You're able to label for last that graph. You can just give it a try. Are you able to share your screen?
No, I'm using my phone.
Oh, okay. But you can guide us, yeah. I need us to put a title here and the Y and X-axis label here. Our code is this. I need
PLT.
Okay, PLT.
Dot X label.
X label.
Then maybe we close the bracket. And then the opening quotes.
Okay.
And then maybe we write X-axis.
X-axis. Then that is for X-axis. For Y.
PLT.Y label.
Yes.
Then we open quotation.
Yes.
And then we Y label. Y-axis.
Okay. Like that. Then the title.
Okay, the title PLT.
Yes.
Dot title.
Dot title.
Then we open.
Yeah.
And maybe now the name of the title that we want to use.
Let's just call it scatter plot. And then we can just run this to see the output. Yeah, good. I think you are right. That is good. I can see you are following. Any other person who is willing to do the labeling for yesterday's graph? It's just as simple as that. But I think we can just move forward. This is all about scatter plots, and we have an explanation here. We are told that the x-axis shows how odd the car is, and the Y shows the speed of the car when it passes. So the first thing that you ask yourself is whether there is a relationship between the observation. Now that you have drawn that scatter plot, can you observe, is there any relationship between the car speed and how old the car is? I think you can just move here. So we are told that we have the speed, the speed of the, is it the speed? I think let me confirm that. At least so that we can derive some relationship. What is this? We have x-axis shows how old the car is, and y-axis will show the speed of the car. So we can just like relabel these here. We have our x showing how, let's call it age of the car, and this one here we can see the speed of the car. I think with that we can try to see how they relate. So we are told that when the car is at age of this is around like, is it 17? Yeah, it's like 17. We are told the car will travel at a speed of, is it around 85? We have when the car is at age of, yes. Sorry, someone is asking a question. Who was that? Any question? Any question?
Sorry, no question, no question.
Okay. Let's just see these plots. I guess some of them like this one. I think it should be somewhere below here. But when you are doing some scatter plots, you will see that this kind of data point is quite off the. This is what we said. You need to like clean the data before even thinking of drawing, because there is no way that a car of age 12 years travel at a speed of maybe around 30, and a car of 17 years to have its highest speed is around 85. So this is, you will definitely see this, that when we try to draw do we call it if we were to draw maybe a gradient line here, you will notice that this one is far from our line, our gradient line, because I'm assuming that it will pass around here. So this is as a result of not cleaning the data. That's why you can see it's verified again. Yeah, so we have this relationship when the car is at age of 12, it has a lower speed, but we can see when the car is at at 2 years or maybe 2 months, you can see it can it has a like a good speed which is above 110. So the relationship here is as the age of the car advances, the speed of the car will reduce, but there are some other factors to consider. This one is just for like, it's just an example, because there you can find old cars which still retain the initial speed. So that is the relationship in our graph. When the age of the car advances, we have its speed lower. So that is it. That is the kind of relationship I think we were to check at that point from that graph. So we are told that it seems that the newer car, the faster it drives, but that could be a coincidence. So after all, we only have 13 registered car. So I think that is that. So as you guys have learned that those graphs are just drawn to like visualize the data. I think when if you are given data of this kind, you could not easily draw like the relationship up to the point that you draw such a sketch, a scatter plot. And then from there you're able to draw some relationship. That applies for every data. When you visualize every data, you're able to like have you will clearly like see or perceive the relationship between the data points. I think that is that. Now, so again, we can have another plot here, and this time around I need us to draw some bar graphs. And I have an example here, a very simple example. It's just quite a simple example here. I think so far you guys have seen the power of Python when it comes to this data analysis field. So you will just repeat the process, and then you can just have that bar graph. And let's just run through this and then explain the code. We have very good bars here. We have the bar A, bar B, then up to D. So again, we have that function that is that allow us to draw these bar graphs. Just by invoking this function here, we're able just to like display the whole like you're able to draw these graphs. I think Python it has some useful libraries, because if we were to draw these minus libraries, I think we could maybe write more than 20 lines of code, or maybe it can go up to maybe 50 lines of code. But by use of this Matplotlib library, we are able to like visualize these by just 6 lines of code. I think Python is just like it's just good for data analysis. So this is the function that we use, and we'll just pass to 2 parameters for this case, or arguments, that is the x and y. You guys can just go ahead and label these out. Just try to label these out. You can even go ahead of saving that file. There is someone who asked me how to do that. You can see we have some few buttons here to you can expand that. You can expand that. You can, as well as you can decide to save the results, and then you can just see where to save. You can just choose the right name here. For my case, I won't save that. Yeah, I think that's all about the bar graphs. But I think we can have, these are vertical bar graphs. I think we can draw some horizontal graphs, bar graphs, so that we can maybe compare them. So let's just have that example. Here is just right here. So we have horizontal bars. If you want bars to be displayed horizontally instead of vertically, use the bar h function. Anytime you want to do anything, you just invoke a function. There is a function like for everything here. So you can just add a h here, and everything will just change. Isn't that awesome? I think just by adding a h here, you're able to have the horizontal bar graphs again. So you can practice on these using other data sets. I think the data sets I've already shared with you. You can draw some bar graphs. Like I remember we had a data set for exercises, this one, and we had some exercise type, duration, calories burned, heart rates, dates. I think you can try and draw a graph of exercise type against burned calories, or maybe no. It's duration against calories burned, or maybe the heart rates. And how we do that is just I think I already show you how to read these. I think we will have an example. We will have an example for that. For that, I'll show you how to go about it. But let's first of all familiarize ourselves with these type of graphs. The other type of graph, we have a histogram. I think everybody has heard of histogram. And histogram is a graph showing the frequency distribution for those who have heard about it. And it is a graph showing the number of observations within each interval. So I don't think I have to explain much about that, but in Matplotlib we use the hist function to create histogram. By using this function hist, we are just able to draw some histograms. So here the hist function will use an array of numbers to create histogram, and the array is sent into function as an argument. I think we have all seen that, passing some array as an argument in functions. So without wasting much time, let's just have an example. For this case, we will use random data. Let me just show you how we can generate some random data here by use of three lines of code. Let me just show you this. Our first point is to import this numpy, and then we call that numpy. We want to numpy has a random function that will help us to generate some random numbers here. We can just run through these. You guys, you can see we have just created some random numbers. They are about 250. Is it 250 rows? No, about 170 rows. This is how we use the random function to generate some data. This is the data that we are going to use in drawing our histogram. So for simplicity, we use the numpy to randomly generate an array of 250 values. Yeah, so where the values will concentrate around 170, and the standard deviation will be 10. So these are the values that I'm talking about. That is 170. This one shows it will indicate the where we want our data to be to revolve around 170, to concentrate around 170, and we have a standard deviation. For those who have done some statistics, you know that we have a standard deviation. It will be of 10. And then how many values we want to generate here? That is 250 of them. I think I had confused between 170 and 250, so it should be 250 rows of data. So, and then we can just let's just have that graph drawn here. Let's just see if we already have it. So we have, first of all, we have to we import numpy, and then for protein we have to import our import matplotlib, and we want to use this module for pyplot, and then we wanted to import it as plt matplotlib, yeah, sure. And then we have we want now to plot this, so we use the plt, and then we invoke the hist function, and then we just want to show the plt.show function, and then we can just comment out that, and then we just good. We haven't passed our values here as an argument, so, and then we just run this, and here is our histogram. We're just using, is it five lines of code? We have a whole histogram here implemented. So any question, you can add titles. There is no difference when it comes also to histogram, titles, and labeling of axis. So any question about that? I just delete this. Any question? Any question about histogram, or maybe scatter, or any question about plotting? You can just ask any question, and if you need maybe some clarification.
I have a question.
Yes.
Okay, so the difference between the histogram and the bar graph, is it possible to make the histogram with the space like the bar graph in between those, like Fishikana, I don't know.
Oh, okay, that is a good question. Any other question? I think I should take all the question first, and then maybe we try to answer that. Any other question? Or maybe
Okay. So the first time we did importation of Matplotlib, and then the one that you've just done right now,
yes,
you started with NumPy instead of starting with Matplotlib. So does it affect?
Another good question there. So I will start with the UBAT question. There is no difference either by starting with NumPy, because you will realize that these libraries, we use them whenever we want them. So there is no like sequence in which they should follow. You just call them when you want them at any position that you want to call them. I think I think that is answered. The other question was about these histogram of ours. By default, these hist it's called the hist function will enable us to draw some histograms that are joined. But I think you can easily create some spaces. You can create some spaces between them. But for our case here, we just in our case here we just need them like to be joined, so that maybe we can clearly see the we can clearly see the that our the data set that we just created is like it's just I think we had in during the generation of this data set, there is something that we specified here, that we want our data to revolve just around 170, and I think we can just we can clearly see that because you notice we just need to compare this, but you can easily create some gaps in between these bars. I'll give you a function to do that, or what parameters you should pass in the hist. But something important that I wanted to put across is that you guys, you can see like from 160 to 180. This is why we have kind of large points of these data of ours. We have the largest bar at around 170 here, but the other largest point, they are around, they are just close to 70, like it is 160 and or 180. So this is kind of the relationship, like we did mention here, well, like creating a random values. I think having said that, I don't think if there is any other thing that I needed to say today, but I think that is that with yeah, with those plots. There are others, by the way. I think during our next lesson, we will just finish up with the plots, and then we go to other concepts, and then just to remind you that I will share your main exam on Thursday after class. It will be a project that will cover all what we have learned, and it will take up to 70 points. So as I had mentioned earlier, that our class today was to end at 8:10, and I can see it's already 8:08. So you guys, you can just ask any question. There is Hubert again. He's asking a question. Just unmute your mic.
Yes, about yesterday's notes and today's, I think I couldn't open mine. I don't know why. So maybe you can resend them, or
you are opening them using what application?
both VS Code and Anaconda.
Oh, okay, I'll share those.
Same.
Okay. I'll share the notes again. Any other issue? Or a question?
So I'm trying to run my codes. Yeah, in VS Code, but I'm not able to run them. I don't know why.
Are you able to share your screen, maybe, so that we can see what could be the problem?
Yes, I can share my screen.
You can just share your screen just for a few minutes and see what could be the issue. Let's just check these. Are you able to expand your screen? And okay. Okay, can you hit the run button? Okay, choose the Python environment. Is that Python 3 point something I'm seeing there? You can just choose the Python, that Python point 3 point. Is it 3.11? What can I see there? You can just choose the yeah. It will soon run. It's connecting to kernel. Allow access. Any other person who is experiencing the same issue?
Yeah, mine too.
I think you should be able to. Okay, let's see this first and then. So after connecting to kernel, it will run. You can just give it some time, some minutes to create that environment. And then if it persists, you will reach out to me. Okay, Hubert. Okay, Priska, you can also share your screen. You will see. Are you still using the phone? Priska.
No, I'm not using the phone. My VS Code is not reading the notes specifically.
Oh, okay. I'll share the notes again.
Okay.
Yeah. So, any other question? So if there is no other question, we can. Okay, before.
I have a question.
Yes, Haji.
Okay. So after we have made about to make bar graph histograms, have you forgotten pie chart? I don't know pie.
Yes, I said in our tomorrow's lecture we will cover that, the pie chart, and then I said the pie chart. We will cover about the pie chart and other type of graphs we usually use during visualization.
Okay.
Yes, there was a question here about someone who needed to put some gaps here. You can add a parameter here that is called the R, the R wing. I think something of this sort. Then maybe you can pass a number. Let's see how it rolls. Yeah, I think this one works. This is how we do it. We just pass. We add another parameter in our function. That is the row width of 0.7. But for our case, I needed it to be joined. I think you have seen that. Yes, I think that is that. We can just close today's meeting and allow me to wish you a good night as we wait for tomorrow's class. So guys, let's meet tomorrow. I'll share the notes. Bye.
Thank you.
You're welcome.
Bye.
Yeah, thanks.